Okay, everybody, good afternoon to you. And so before I get out my notes for you guys, I just want you guys to know we're going to look at data that's known as bivariate data. So let's look at the words bivariate. Bi has a prefix of 2. Variate means what? 2 variables. So this is going to look familiar. It's going to look like something you might have seen from beginning algebra, okay? You got an x variable and a y variable. So you're going to gather bivariate data, 2 variables. Okay? So you can have a population where you take a sample. So here's my population. We're going to take a sample. And what you really care about is the following. We're going to care, is there a linear correlation between x and what? Y. Okay, now we have to look at this key phrase here called correlation. And that's what we really look for. That's what we're really looking for. Is there a correlation? So you might say, what does the word correlation mean? I'm not going to ask the AI because I don't get any what? I really don't get any service down here. So when they say correlation, they want to know, is there a relationship? Okay, is there really a linear relationship? Now, when they say the word linear, this is where algebra comes in. Do you guys remember linear equations in algebra? Y equals what? Mx plus b. So we want to know, is there a linear correlation between the variables? So we're going to gather data now from 2 sets of data. Or I should say 2 data values. So, for example, I used an example in the last class, okay? And I said to them, okay, we're going to let X represent your sleep hours. And we're going to say Y represents your test score. Okay, so your sleeping hours, how many hours of sleep you got? Bless you. Y is the test scores. And the sleep is measured in hours. Test score is measured in percent. Now the X variable and the Y variable, okay? So we're going to look at some data here. And so in Microsoft Excel, for the last class, we already have that kind of data already looked at here, okay? See how that looks? Yeah, there we go. So on the left side, you have what? The X values and the Y values. On the right side, this is bivariate 2 variable data. So we want to know, is there a correlation between the amount of sleep you guys get, like the night before a test, and how well you do in terms of a percent? What do you guys think? Is that kind of interesting? I wonder if there's a linear relationship, if there's a relationship between the amount of sleep you get and then your test score. So remember what I said here, though. Where does this come from? This is math. So if you recall, that linear equation what they want to know. Generally speaking. Your x-axis and your what? Y-axis. So when you plot your data here, this is what your data can look like. Right? You plot these two values as if they're from beginning algebra, and then you're trying to determine, is there a line here that I can fit the data values on? Because that's what we mean by a linear relationship, right? They mean by a linear correlation. Can you find that y equals mx plus b? Now, this line has a very special name. This is called the best fit what? Line. Now you say, why do they call that the best fit line? Well, it's the kind of line, we should say, that can best fit the data. You know, that's what they mean by that. It best fits your data. Your line will fit on that data. Now, it doesn't exactly. It's off the line. But I would say, yeah, it looks like it may do that, okay? This is also known as, by the way, the what? The regression what? Line. Okay, your best fit line, the regression line. So if I go back and I say to you guys, look at Excel. Excel does have a way to plot data. So I'm going to plot the x-axis and the y-axis. I'm going to go over here. We're going to say insert a what? A graph here. Insert that. Okay? So this is plotting your data. I can even, I think we can do, where can we find that? Where do we put? No. Where is it? Where is it? I think it's a, is it add? No. Where is it? Draw. No. Data. Insert. There's actually a way to put a line there. But you're actually looking at your data values there, okay? And this has a name, so let me see if I can find it. Let me see. I'm going to Google it over here. Yeah, select a chart, select the plus. Okay. So here's your chart. Where are the dots? There we go. Oh, I think it might be. Okay. Wow. There we go. It's right up here. You're going to insert a trend line. Okay, there it is. Thank you. You have to double click on it. Okay. So what are you guys looking at, ladies and gentlemen? We are looking at two very important things. Very important. What you guys are looking at is your data in a scatter plot. So you have a scatter plot on that data, and you see that line? This is that best fit line. So your data can actually fit on a line. Now you might say, why do you care? Well, if we can find that equation, we can now be predictive. So here's an outline of the idea. When you find this equation, this best fit line, the regression line, okay? The reason you care about it is so you can be predictive. You want to predict what happens between the variables. In other words, if I can tell you, hey, guess what? If you get 12 hours of sleep, you're going to get 100% on the test. If I said to you, if you get 10 hours of sleep, you're going to get 100% on the test. I can now predict what your test score will be based on your sleep time. Now, the X variable is called an independent variable. This is independent, meaning it could be anything you want in theory. Not really in practice. You can't sleep for 20 hours. Well, maybe you'll try. Okay, and then your test score is a dependent variable because it will depend on the value of X. So the whole idea is to get a hold of this line called your regression line or the best fit line, and that will allow you to predict, or I should say be predictive. And that is a sketch of the idea that we're going to do. Now, I'm going to give you guys a quick break because when I come after, or when we go, let me do this before I give you guys a break. There is a process to enter bivariate data in Microsoft Excel. Sorry, in the TI. So let's take a look at this. So if I say go back to the spreadsheet, I'm going to enter this bivariate data and I'm going to create the scatter plot because that's what this is. It's called a scatter plot when you plot your data values. Okay? So let's share with you guys how you do that. Do you guys remember how to enter a list? Do you guys remember how to enter a list in the TI? How do you do that? Stat, edit, what? Good. Now, I did this earlier. We're going to clear out L2. And we're going to clear out. Go up to the title and hit clear. We're going to clear out L1. So what you guys want to learn how to do is enter bivariate data. The X always goes into L1 and the Y always goes into L2. So what's your first X value? Okay, I'm going to scroll out here so people can see the details. So we went stat, edit, edit. Let's enter the data values. The first data value eight, 6, 4, 7, 6, 9, 0, 2, 9, and then what? 7. Okay, so these are all the X values. Let's put the Y values. 92, 74, 38, 80, 80, and then 90, 20, 30, 100, and then what? 99. All right, you guys okay with that one? Scroll in. What you have is called bivariate data. Now, I'm going to share with you guys again. We're going to create the scatter plot, okay? We're going to plot the X and Y values in your TI calculator. And that's what we're going to be doing over and over again, okay? We're going to go through the process using the modern method. So here's our data. Let's show you guys. And of course, you have notes on it, and you'll see the details. I'm going to go. You see that upper left? It says stat plot. See stat plot in the upper left? It's blue. So to access it, I hit the second key, and I go to stat plot. And so all the statistics plots come up. And it's on 1, which is blue. So I'm going to hit enter, because that's the one I'm going to use. Now make sure it's on, and then make sure it's on the first one. You see that first one? That's a statistics, I should say to you, that's a scatter plot. If you want to take a look at the others, this will be like a frequency polygon, a histogram. This is a box plot that displays the outliers, and here's a box plot without the outliers. And this is also another important feature. But we're going to the scatter plot, okay? So make sure it's on that first one, scatter plot. And then this is important too. Make sure your X variable is on L1 and the Y variable is on L2, because you say, why? We put the X values in L1, we put the Y values in L2, and then all of those marks, we have an option down here. It could be like a circle or a box. It could be an asterisk. It could be a dot. I put the dot because it's a point. And we're now ready, ladies and gentlemen, to try to see the scatter plot. So I do have these instructions for you on notes, like I always do. I always give you guys instructions. Now we want to do the following, okay? You're going to go to the zoom key. They're in gray. So like think of it as zooming into that picture. So we're going to zoom into that picture, scroll down to zoom stat number 9. And hit enter, and what do you guys see? What you should see is a scatter plot. So this is how we go about this data. It's a scatter plot, okay? All right, you guys okay with that? Now you might say, wow, and I'll ask you, does it look like your data can fit on a straight line? Does that look like your data fits on a straight line pattern? And I'm going to say to you guys, well, maybe, but we're going to have to test this. We're going to have to now that we see the data can possibly fit in a straight line pattern, we're going to have to go out, we're going to do a formal hypothesis test. And so for that, I'm going to give you guys a little bit of some background, but don't worry. It's going to be easy peasy because we're going to use the TI. The TI is going to tell us everything. Do you guys want to see it now, or do you want to take a break? Let's take a what? Let's take a break. So I'm going to give you guys a quick little break, okay? And then we're going to proceed to the process. It's going to be an amazing process for you guys. Take a nice break for you guys.